Good morning. Let's see, today is Sunday and it's midnight. So we should probably, get started working. So what are we working on today? Well, the first thing I need to do is we're getting stuck. We're getting stuck in stuff. And what I need to do is I need to change our movement stuff so that it's got a little bit more of a buffer between stuff that you're going to be running into. So let's start out. So the thing that's happening is, after the latest check-in stuff, I was noticing that we were getting stuck on some walls and some stuff like that when we were in the air. So we're gonna debug exactly why that's happening. So let's take a look. So what I was noticing was when I was over here, when I jumped, I would get stuck in the wall here, right there. It's like when I would jump, and then I'm stuck. So let's take a look. So obviously we're in the air. So let's have so let's add some tracing right here. So let's see, we want check if stuck right here. Right, we are stuck after I guess it's moving along a wall. So let's see what happens when we do this. Because I think what happens is basically our box is coming down and then all of a sudden we're inside of the object. I'm wondering if I should change some of the logic otherwise. Like maybe I should set it so it has an inflation on the bounce check. I thought I had saved it. I have not. Alright, cool. Yeah, good morning, Kirakin. I'm going to be working on movement stuff today, so I'm just fixing some bugs that I found. Alright, so we are stuck moving along a wall is what's happening. We are stuck after moving normally in the air. Okay, so interesting. So we actually got ourselves stuck here. It has to do with these sweep tests and some of the other things just not returning what we thought. So we need to put in some basic sanity checks on a lot of our movement code to keep us out of the wall. Because we're basically always dealing with a quantum bitey who likes to phase through matter and then embed himself into the wall, so it can't go anywhere. Classic horror movie material? Yeah. Classic science fiction horror. It's pretty clear that we're having some issues moving along this wall. Like, oh, we got stuck. So we got stuck moving along the wall. Yeah, so the moving along the wall code is also problematic. Okay. Alright, so let's take a look. I don't know what bug you're referring to, Kirkan. If it is, then it's just something else that I meant, that we noticed the same thing happening. So what is this thing doing? It is basically... Yeah, I need in motion magnitude is greater than tiny float in order for this to happen. Yeah, well, it looks like there's definitely some issues with getting stuck in the wall. And re-importing, collision and stuff like that can always change some of the math behind some of it to make a problem more or less likely to occur. But it appears that basically the code that has to do with moving along the walls and stuff like that is not the best, and has some rough spots. And that's what we found a lot. Well, it's not getting stuck. That's landing on an actual, thing in the wall. That's not stuck. That's landing. And what's going to be going on there is that's a different thing. That's basically there is actually a tiny platform that you can land on there because the geometry of that segment actually has like a little landing spot there. You can't see it, but it's there. So that's something else. Like if you put two things right on top of each other in real life, right? Like you wouldn't be able to land on that tiny little edge, that imperceptibly small edge that is going to be there. Because like what's going on is you got two blocks kind of like this. But if you magnified it, it's basically that there's a little tiny thing right there that Bitey can land on with just the corner of his foot. So it's a legitimate landing spot. So it's a problem with the level. At least that's probably what it is. Because the thing I'm dealing with right now is where, because of mathematical imprecision, at the halfway point right here is causing us to actually get kind of embedded into a wall, which is a little bit different. Where we're actually stuck, we cannot move in or out or anything. It's a lot of vector math stuff that we're doing to move everything, and it may be that we need a simpler solution for some of this. You know, at some point here, there's only so much you can fudge numbers and screw around with math before it's just like, you know, the physics simulation is just going to be wrong, so we can't rely on it for this sort of movement. How in the hell did we get stuck there? Like, we specifically said if you're not stuck, then move, otherwise don't move. Yeah, it's interesting, just all these different things. Yeah, but if the math is just going to keep breaking down on me, I might have to just do something completely different. Did he change the movement stuff again? He needs to stop doing that, because I need to make a copy of it. Let's see, content, characters, bitey, movement. Yeah, he changed it. Yeah, that's... I can totally feel it whenever Adam changes that movement. I just... it feels awful. Alright, so the problem is we're not sliding nicely down the slope there. So what exactly is going on with that? Why are we not nicely sliding down the slope? Well, it's going to be... we can't land. We're going to apply wall friction. Alright, well, it's starting here, basically. We push ourselves by the collision normal and a small amount. So let's see. It's actually pushing ourselves off the wall. Otherwise, we're going to say couldn't push ourselves off the wall. Yeah, once we fix the basic movement stuff that we're having some trouble with, we'll be able to move on to the actual movement stuff. And what we're going to be doing is the more bitey-like movement, where we actually have to press buttons in order to get bitey to do things. Such as we'll try to run, and there'll be a whole bunch of stuff we have to deal with, and I'm not exactly sure. We'll have to design it and figure out exactly how we want bitey to work. So it looks like we're never having an actual issue with pushing ourselves off of the wall. So maybe one of the things we can actually do is push ourselves a little bit farther. Because we're pushing ourselves right now 0.1 centimeters. I think we should push ourselves farther than that. Let's try pushing ourselves like maybe 2 centimeters outward or something like that. Because what's kind of happening is we want to push ourselves off the wall that we'll be sliding along so that we can actually slide along it without getting stuck too horribly inside of it. We'll probably also have to push ourselves off every iteration here. Interesting. We're not pushing ourselves off the wall except for like could not push ourselves off the wall for 1. That's a positive Z. So why are we actually getting wall friction here? It's like what's happening is we should just jump straight up and have absolutely nothing going on. But it's not. So what is going on here? It's so we'll see. There's some condition that's getting flipped here that doesn't make sense. Like, we should be pushing ourselves off the wall if we're here, but it's like this code for moving along the wall is not doing anything proper. Like, it's as if just our normal sweep movement stuff isn't able to move us. But I'm not sure why it would trigger us to start falling faster. We're not actually falling faster, we're just not able to move. And it has to do with this check. Basically, our movement distance, like we're supposed to sweep up in a direction, and we're not colliding with something. So this check right here basically is returning the wrong data. Like, we're not able to move because we're actually striking something when but we shouldn't be. So what exactly can we do about this? I mean, it's clear that there's something with our sweeping of our object here is wrong. There's something going on where we are not colliding when we should. Like we have jumped, and all of a sudden we sweep upwards, no collision, and then when we try to put ourselves in that position, we collide. Alright, so the direction is straight up. The collision happens. We have a blocking hit, 0 penetration. Do we have any hit at all? No, it looks like it didn't hit anything. Collided false, position, direction, ray distance was 52, collision distance is nothing. So let's check our distances. The thing that's going to change is the Z, so 40931.046. Alright, so we have 196158, 6158. The distance should be like 52. So I guess we just gotta print everything off. So far I've just been not very impressed with the consistency of the physics engine. I think it's disappointing. Alright, so if we sweep our object, Alright, so we have the position, direction, distance, all this sorts of stuff. We're going to go through and hits is empty. The distance was 52 plus this 0.5. The direction was 1 up. And was hit was false. And I guess it still has to do with some other stuff here, like maybe if we're casting the ray down by a very small amount, we hit something. But why would casting the ray down as opposed to up, which is the direction we're going, do anything? So the position is the correct position. Alright, so the hits, we actually do have a hit, and it's saying basically you're already inside of the object. I mean, that's start position. The Z is 40930. The Y is 196. It's 158. 158.8. 158.8. 4092. 4930. The ray distance was 2, the move distance was 2. See if this B trace complex does anything. Well, let's see if changing the trace complex does anything for us. See if that does anything. And basically, like, I'm not really sure exactly what to do with this movement code. Like, if it just keeps doing this where all these ray traces and all this stuff is just unstable and continues to have penetration issues where stuff gets stuck inside of each other and you trace one direction and it gives you a different result as if you trace another one, then I don't know, might have to redo the movement stuff from scratch. Because you can't build a complex movement system on top of stuff that doesn't give you the right answer. Like, you just can't do it. You can screw around with it and kind of munge it to try to get it to do what you want, but if it's not going to do what you want, like, it's like, you know, I want the answer. Am I going to collide with something if I move here? And you're like, no. And it's like, okay, and then you move there, and it's like, oh, well, you're colliding with stuff. And be like, well, what the hell? Like, what are we supposed to do about that if the answer changes every time we test? Like, it needs to be at least consistent. Well, it looks like that trace complex actually did do what we wanted it to do. Because we're no longer hitting this breakpoint. Alright, so it's just literally this complex tracing is screwing us over. Well, if that's literally what we need to do, then we should probably try getting rid of everything that we just had. Yeah, I mean, that was clear. If you're looking at the numbers there, was basically you do a sweep to a position and it returns that it doesn't do anything. You know, it's like, oh, we sweep to a position. Will we collide? And it's like, no, you won't collide. And then you put the object at the position where at the end of the sweep, and you're like, all right, well, did you collide with anything? And it's like, yes, I did. You're like, well, you know, obviously that's just wrong. And the reason for the difference was because when we tested it before, was the direction vector was up, and then when we tested it when the direction vector was down, it was wrong. somehow. So we've removed all of our kind of hacky logic. Yeah, that was it. Alright. Well, let's make sure we've got that set then. How does the direction make a difference? That has to do with imprecision and floating point values, where it's basically in order to test if something was there and colliding, it's sweeping the object in a certain direction. So if it's sweeping an object in a direction, the math, the numbers that you put into the black box and shake around are different. And because of precision issues in math, you will get a different result just because you had different numbers. Even though those numbers should add up to the same things, they're different numbers. So they will be different because of small variations, and the answer should always be the same in a consistent system. Like, it's okay if it's a little bit different, but it should at least say like if you collided or not, or it should guarantee that it'll be the same sort of screwed up. So let's go to our physics utils, and what we're going to look for are, every time we have these collision query params, we need to make sure we have complex set properly. And I think we had been messing around with this before, where I didn't know what that did. Alright, that's better. And this might mean we can actually, like, we were using a lot of sweep checks and stuff like that before, and we replaced a whole bunch of stuff with sweeps. We might be able to do the overlap stuff and revert some of our previous shenaniganry. And of course, here is another issue. We're having the same thing happen. Yeah. So by turning on that complex collision, all of a sudden we're getting it so when we move, we just fall through the platforms. And now we're getting stuck on other things. What is going on here? Just by pressing the down key, we were falling through. Alright, well I should switch levels, I think. So the issue was right here. That tiny little lip there was screwing stuff up, and then also these platforms, when we're standing on them or falling through them. So it's probably that the trace complex stuff is messed up. Is not messed up. It's probably correct, and we've been relying on its imprecision or something. So let's see. This is going to be a problem with the mantling code. I think I'm going to need to change the physics utils. This physics trace tag. To something else. That way I can debug this a little bit better. So let's see. If we're failing to mantle, why would that be?